Example 29, water is moving in a rectangular channel to have a Froude number of square root of 10, which is greater than 1. So this is in the lower stage. So hydraulic jump can occur because this is in the lower stage. The channel is 5 meters wide and the depth of flow is 1 meter. If the water undergoes a jump, compute the following: the depth of flow after the jump, the Froude number after the jump, the head loss. So take note that in example 27, we derive a formula for depth after the jump for rectangular sections and the Froude number after the jump, as well as in problem 28, the head loss shortcut formula. So it is a test if you can remember those formulas. So depth 2, remember, is depth 1 quantity, depth 1 times quantity square root of 1 plus 8 FR1 square, square root of quantity 1 plus 8 FR1 square, close, minus 1, then quantity all over 2. So depth 2 is equal to depth 1 times quantity square root of 1 plus 8 FR1 square minus 1 all over 2. That's the direct formula. Since this is given, then depth 1 is 1, then we can compute depth 2. So 1.0 square root of 1 plus 8 times square root of 10 square minus 1 all over 2. So this is 81 square root 9 minus 1, so 8 over 2, 4 times 1, so depth 2 is 4 meters. Then the Froude number after the jump, we also derived that in problem 27. And it is equal to FR2 is equal to 2 square root of 2 FR1 all over quantity square root of 1 plus 8 FR1 square minus 1 to the 3 halves. If you can recall the formula. So 2 square root of 2 FR1 over quantity square root of 1 plus 8 FR1 square, close, minus 1, quantity to the 3 halves. Substitute FR2 is 2 square root of 2 times square root of 10 all over 1 all over square root of 1 plus 8 square root of 10 square minus 1. So the denominator is 8. This is 8. So 2 square root of 2 square root of 10, then divided by 8 to the 3 halves. So FR2 is 0.3953. So that's why this is in the lower, this is in the upper stage subcritical flow from supercritical flow. A jump can occur. Then finally, the head loss, the direct formula is quantity depth 2 minus depth 1 cube over 4 depth 1 depth 2, which is in problem 28. Depth 2 minus depth 1 cube over 4 depth 1 depth 2. So substitute 4 minus 1 cube over 4 times 1 times 4. So it is 27 over 16 or 1.6875 meters. Now what if you do not know all this because you cannot find this in the reviewers? I'm just the one who derived this for you as a direct formula. You can still solve the problem as long as you know the hydraulic jump formula for rectangular sections, which is small q square over g equals depth 1 depth 2 over 2 times quantity depth 1 plus depth 2. So, but before that, we begin with Froude number at 1, which is v1 over square root of g depth 1, so that we can compute v1 as well as the small q, the q. So fr1 equals velocity 1 over square root of g depth 1. So v1 is 9.9045 meters per second. So small q is q1 also equals q2 equals depth 1, which is 1 meter times v1, 9.9045 by continuity equation. Having found that, substitute into q small q square over g equals depth 1 depth 2 over 2 times quantity depth 1 plus depth 2. So this is needed so that we can still solve this problem without this very without these formulas, which are unfamiliar maybe to you. So substitute 9.9045 square over 9.81 equals 1 times depth 2 over 2 times quantity 1 plus depth 2. Cross multiply 2 times 9.9045 square over 9.31 equals depth 2 square plus depth 2, or depth 2 square plus depth 2 minus 20. This is 22 times 9.9045 square over 9.81 is 20. Then simplify equals 0. So factor depth 2 minus 4 times depth 2 plus 5 equals 0 because we can easily factor that. So depth 2 cannot be negative, so depth 2 is 4 meters, just like this. Or use your calculator, solve for this quadratic equation. Then, for the Froude number after the jump, because there is depth 2 already, it is equal to V2 over square root of G depth 2, where V sub 2 is small q, which is 9.9 over 5 divided by depth 2, which is 4. So 2.476 meters per second. So FR2 equals velocity 2.476 over square root of 9.81 times depth 2, 4. So solving for FR2, it is also 0.3953. This is the same as that. And finally, the head loss in the jump is specific energy at 1 minus specific energy at 2. Specific energy is velocity head at 1 plus depth 1 minus specific energy at 2, which is velocity head at 2 plus depth 2. So head loss in the jump is 9.9045 square over 19.62 plus 1 minus 2.476 square over 19.62 plus 4. So computing using your calculator, it will give us the same answer of 1.6875. So if you're not familiar with these direct formulas, then stick to the principles and formulas for hydraulic jump in a rectangular section or channel.